All right, welcome everyone. In this explainer, we're going to break down a mathematical tool that is, and I'm not exaggerating here, one of the most powerful and practical things you'll have in your business toolkit. We're talking about matrix theory. Now, I know what some of you might be thinking. Matrix theory, it sounds a little intimidating, maybe a bit too abstract. But I want you to push that thought aside, because what we're really talking about today is your future secret weapon for making sharp, strategic, data-driven decisions. So let's start with a massive question, one that will follow you for your entire career, whether you're a manager or a future CEO. It doesn't matter if you're running a small startup or a giant multinational corporation, you will always face the challenge of limited resources. You only have so much money in the bank, so many people on your team, so much time in the day. So the big question is, how do you take all those limited things and allocate them to get the absolute best possible outcome? That is the core puzzle of business. And today, we're going to start unpacking the tools to solve it with real precision. The answer to that huge puzzle starts with something pretty basic: organization and structure. There's an old saying in management that is absolutely true. You cannot optimize what you cannot clearly measure and see. And the best tool we have for taking complex, messy, multivariable business data and getting it organized is the matrix. I want you to think of it like the quantitative blueprint for your business. It takes a total jumble of information and transforms it into something clear, logical, and incredibly powerful to analyze. So what exactly is a matrix? Well, formally, it's just a rectangular grid of numbers, what we call elements, all neatly arranged in rows and columns. And you might be thinking, hey, that sounds just like a spreadsheet. And you're not wrong, it looks a lot like one. But its real power isn't just in storing the numbers, it's in its mathematical properties. You see, each number's value is tied to its exact location, its specific row and column. This rigid structure is what allows us to represent really complex relationships, like sales data across different products and regions, in a format that we can then apply the powerful rules of linear algebra to. Okay, let's make this real. Here, we see that abstract idea made concrete. This is a simple 2x3 matrix. It's showing the sales of two different products across 3 different regions. Now, take a look at the element in the first row and the third column. See that? That isn't just the number 680. It represents 680 units of product A sold specifically in region 3. And instantly, just by having this structure, we can start analyzing. What were our total sales in region 1? Simple. We just add up the numbers in that first column. 500 plus 400 gives us 900 units. Which product was the top performer overall? Well, we just sum the rows. Product A sold 1,930 units, product B sold 1,550. The structure itself immediately starts giving us insights. But the real magic of matrices isn't just about storing data, it's about manipulating it. Let's say we had a sales matrix for January, just like the one we saw, and another one just like it for February. If we wanted to find the total sales for both months, we could just perform matrix addition, literally adding the corresponding numbers in each grid. Even better, what if we wanted to model a projected 5% sales increase for next quarter? We could use something called scalar multiplication. We just multiply every single number in our sales matrix by 1.05. You see, this isn't just a calculation anymore, it's a simulation. These operations let us model scenarios, analyze changes, and make real quantitative predictions. Okay, so let's scale this whole idea up. A lot. We're going to move from looking at a single company's sales data to the macro level, to modeling the entire interconnected machine of an economy. This is where the truly profound analytical power of matrix theory really starts to shine. Think about how incredibly complex a modern economy is. A steel mill makes steel, right? But that steel is an input for a car factory. The car factory builds cars, which are then used by a delivery company. That delivery company transports food, which is an input for the restaurant down the street. It's this huge, tangled web of dependencies. A little disruption in one area can send shockwaves through the whole system. So how could you possibly keep track of it all? Well, this slide shows the brilliant solution, known as the input-output model. What you do is construct a massive matrix. In this matrix, each row represents the total output of an entire economic sector, and each column represents all the inputs that sector needs to create its output. This allows us to mathematically trace how everything flows between industries. So if consumer demand for cars suddenly goes up, we can trace it back through the matrix to calculate exactly how much more steel, rubber, glass, and everything else we'll need to produce. It turns that incomprehensible web into a predictive economic map. Okay, that's the big picture. Now let's bring all this power back down to the level where you'll be operating every day, the individual business.
This right here is the heart of what you need to master. We're talking about optimization, which is really just the art and science of using what you have to get the best possible result. And we are right back to our eternal problem. Pretty much every decision you make as a manager is about allocating scarce resources. Do you put your limited marketing budget into campaign A or campaign B? Do you assign your best engineer to fix old bugs or to build a new feature? You can't do everything. These aren't just little choices, they are major strategic trade-offs. And here's the crucial part. A field called linear programming, which leans heavily on matrix algebra, lets you formally model your business reality. First, you define your goal, let's say to maximize profit. We call this the objective function. Then, you define all of your limits, your constraints, as a system of inequalities. For example, the hours machine A runs plus the hours machine B runs can't be more than 100 hours this week. Or, the amount of raw material we use can't exceed the 500 kilograms we have in the warehouse. This whole system of constraints can be represented in matrix form. And using special techniques, you can then solve it to find the optimal allocation. You are no longer guessing, you are calculating the best path forward. This quote really just says it all, doesn't it? You take a messy, real-world problem with a dozen competing limitations and variables, you translate it into the clean, structured language of matrices, and the solution that pops out isn't just an answer, it's the optimal answer. It is a data-driven roadmap telling you exactly how to use your resources to get the most profit or the lowest cost. Let me be perfectly clear about this. This is not just some academic exercise to get you through a class. Mastering this quantitative way of thinking is one of the key things that separates a good manager from a great one. It gives you a tangible, strategic advantage that will help you for your entire career. Just look at this comparison. It represents two totally different ways of managing. On one side, you have decisions based on gut feelings. You know, the manager who says, let's just increase production on machine 2. It feels like it's our fastest one. That's pure guesswork. It's reactive and it's full of hidden risks. On the other side, you have the strategic approach. That manager says, okay, we've built a linear programming model in matrix form. It includes our production rates, material costs, and labor limits. The optimal solution shows that to maximize profit this week, we need to allocate exactly 38 hours of machine 1's time to product A and 45 hours of machine 2's time to product C. One is professional and calculated, the other is amateur and based on intuition alone. Now, a very important word of warning, because this is one of the most common mistakes I see students and even professionals make. A matrix model is an incredibly powerful tool, but it is not magic. It is a representation of reality, not reality itself. You've all heard the phrase garbage in, garbage out, right? Well, it's never more true than here. If your data on production costs is wrong, your optimal solution will be optimally wrong. If you assume a simple linear relationship when it's really a curve, your model is flawed from the start. A truly great manager uses the model, but they also critically question the assumptions and the data that went into it. So the main thing to take away from all this should be the incredible versatility of this one single tool. Think about it. From mapping simple sales data to modeling huge economic systems to optimizing a factory floor, the matrix gives you a single, consistent, and powerful framework. Once you learn to think in terms of rows, columns, and operations, you have a completely new and more powerful lens to view almost any quantitative business problem you'll ever face. I'm going to leave you with a final question to think about. Look ahead to your future careers. Whether you end up in marketing, finance, logistics, operations, what is a complex, multivariable problem you think you're going to face? How could you start to structure that problem in a matrix? What would your rows be? What would your columns represent? What are the constraints you'd have to model? The moment you start framing challenges in this structured, quantitative way, you are already on the path to solving them more effectively. Thank you.